Good evening. Tonight, you'll discover how our moon was born from cosmic violence, how it shapes the tides, and how it has watched over Earth for billions of years. 100 facts about the moon that will guide you into the most peaceful sleep. But first, if you want more journeys like this, subscribe to the channel and leave a like right now, because in just a few minutes, you'll be too relaxed to move. Now then, make yourself comfortable. Let your body sink into your bed. Close your eyes. Tonight, I invite you on a journey to our closest neighbor, to the pale disk that has inspired poets, guided travelers, and pulled at our oceans for 4.5 billion years. 100 remarkable facts, told slowly, gently, without haste. You don't need to remember them. You don't need to analyze them. Just listen, and let these words become part of your dreams. Breathe evenly, deeply, and we begin. The moon is approximately 4.51 billion years old. 4.51 billion years. Just slightly younger than Earth itself. Born in fire, shaped by time. Constant companion to our world. If you could watch the moon's entire history and fast forward, you would see a glowing sphere of molten rock, slowly cooling, darkening, becoming the silvery world we know today. Everything the moon has witnessed, every moment of Earth's history, it has been there, silent, watching. Our moon was born from catastrophe, around 4.5 billion years ago, when Earth was still young, still forming. A Mars-sized planet called Theia approached. Scientists believe Theia, named after the Greek goddess who gave birth to the moon goddess Selene, struck Earth at an oblique angle. The impact was unimaginable. Both worlds, Earth and Theia, were partially vaporized, melted, their outer layers mixing, merging, thrown into space as superheated debris. This wasn't destruction, this was creation. From the collision, a ring of molten material formed around Earth. Picture it, if you can. Earth, glowing red, surrounded by a vast ring of liquid rock. Droplets of stone, incandescent, orbiting in the darkness. This ring, this cosmic debris, began to coalesce, gravity pulling the pieces together, slowly. Over perhaps just a century or two, the material clumped, and from those clumps, our moon emerged, a second world, born from Earth's own body, forever linked. When the moon first formed, it was much, much closer to Earth. Imagine looking up at the night sky and seeing the moon filling a quarter of the heavens, enormous, dominating, so close you could almost touch it. The distance between Earth and moon then was only about 14,000 miles. Today, it's 238,855 miles on average. Back then, a day on Earth lasted only 5 hours. The moon's gravity, so much stronger at that proximity, spun Earth rapidly, pulled at the young planet with tremendous force. The newborn moon was covered in an ocean of magma, a molten surface, glowing like a small sun, temperatures reaching thousands of degrees. For millions of years, the moon was a sphere of liquid rock, but slowly, very slowly, it began to cool. The lighter minerals floated to the top, forming the bright highlands we see today. The denser materials sank, creating distinct layers within. This process, called differentiation, took hundreds of millions of years. Interesting, isn't it? The moon has no atmosphere, no air to breathe, no wind to blow, no weather at all. When astronauts walked on the moon, their footprints remained perfect, undisturbed, because there's no wind to erase them. Those footprints, made in 1969, are still there today, and they'll remain for millions of years, unless, of course, a meteorite happens to strike that exact spot. The moon is covered in a fine dust called regolith. This isn't ordinary dust. It's been created by billions of years of meteorite impacts, each collision pulverizing rock into ever finer particles. The regolith is sharp, jagged at the microscopic level, because without wind or water to smooth it, it remains angular, abrasive. Astronauts found it stuck to everything, their suits, their equipment. It even smelled strange, like spent gunpowder, they said. The moon, leaving its mark on those who visited. The moon's diameter is 2,159 miles. That's about 1/4 the diameter of Earth, making it the 5th largest moon in our solar system. You could fit 4 moons across the face of Earth. Or, if you prefer, you could fit about 50 moons inside Earth's volume. It's large enough to be considered a planet in its own right, if it weren't orbiting Earth. Some astronomers even call the Earth-Moon system a double planet. The moon's surface is divided into 2 main types of terrain. The bright areas are called highlands or terrae, ancient, heavily cratered, composed mostly of a rock called anorthosite. The dark areas are called maria, the Latin word for seas. Early astronomers thought they were actual oceans. They're not. They're vast plains of solidified lava. These lava flows erupted billions of years ago, filling giant impact basins, creating the patterns we see, the face some call the man in the moon. The largest crater on the moon's near side is called Bailey. It spans 183 miles across, nearly the distance from London to Paris, so large that if you stood at its center, you couldn't see the rim in any direction. The crater walls would be below the horizon. Just imagine, standing in the center of such vastness, grey dust, black sky, silence. If you haven't fallen asleep yet, that's perfectly fine. We have 90 more facts to go. The moon has a feature called the South Pole Aitken Basin. This is one of the largest impact craters in the entire solar system. Located on the far side, it's 1,550 miles in diameter, about 8 miles deep. The object that created this crater must have been enormous, perhaps 30 miles across, traveling at tens of thousands of miles per hour. The impact would have excavated material from deep within the moon, exposing rocks that had been buried for billions of years. Scientists are very interested in this region because it might tell us about the moon's interior composition. The moon's seas were formed by volcanic activity between 3 and 4 billion years ago, when the moon was still geologically active. Magma welled up from below, flowing across the surface, filling the low-lying areas left by ancient impacts. This wasn't explosive volcanism. It was gentle, effusive, like the volcanoes in Hawaii today, but on a grander scale. The lava flows, sometimes hundreds of miles long, slowly cooling, darkening, creating the dark patches we see from Earth. Mare Imbrium, the Sea of Rains, is one of the largest maria. It's 750 miles across, roughly circular, formed by an impact so powerful it sends shockwaves through the entire moon. You can see Mare Imbrium easily from Earth. It's the large dark patch in the upper left of the moon's face as we see it. When you look at the moon tonight, or tomorrow night, or any night, you're looking at ancient lava flows, frozen in time, telling stories of a more violent past. The moon's far side looks quite different from the near side. It has almost no maria, just a few small patches. Instead, It's almost entirely covered in highlands, heavily cratered, ancient. Why this difference? Scientists aren't entirely sure. Perhaps, when the moon was forming, the near side remained molten longer, allowing more volcanic activity. The far side cooled faster. Or perhaps, Earth's gravity somehow influenced where lava could flow. The mystery, like so many things about the moon, continues. The moon is slowly moving away from Earth. Each year, it drifts about 1.5 inches farther. That's roughly the rate your fingernails grow. This happens because of tidal interactions. The moon raises tides on Earth. These tides create friction, and that friction gradually transfers energy from Earth's rotation to the moon's orbit. In about 600 million years, the moon will be far enough away that total solar eclipses will no longer be possible. Isn't that something? Future generations will never see what we can see now. The moon takes 27.3 days to orbit Earth. This is called a sidereal month. The time it takes for the moon to return to the same position relative to the stars. But the time between full moons is 29.5 days. This is called a synodic month. Why the difference? Because as the moon orbits Earth, Earth is also orbiting the sun. So the moon has to travel a bit farther to return to the same phase, time, measured by celestial dance. The moon rotates once every 27.3 days. This is the same as its orbital period, a phenomenon called synchronous rotation. This means the moon always shows the same face to Earth, always, the far side, forever hidden from our view, at least until we sent spacecraft to photograph it. We didn't know what the far side looked like until 1959, when the Soviet Lunar 3 spacecraft flew past and took the first pictures, a mystery unveiled. After billions of years, the moon's synchronous rotation isn't a coincidence. It's the result of tidal locking. Over billions of years, Earth's gravity, acting on the moon's slight bulge, has slowed its rotation until the rotation period matched the orbital period perfectly. This is common in the solar system. Most large moons are tidally locked to their planets. It's a form of cosmic friction. Gravity shaping motion, bringing harmony to the heavens. We can actually see slightly more than half the moon's surface from Earth. About 59% in fact. This is due to a phenomenon called libration. The moon's orbit isn't a perfect circle, so sometimes it moves faster, sometimes slower, but its rotation rate stays constant. This allows us to peek around the edges, first one way, then the other, like the moon is gently nodding, showing us a little more, a little extra, generous. The moon doesn't produce its own light. This seems obvious now, but ancient peoples didn't know this. They saw the moon glowing and wondered. The moon shines by reflecting sunlight. About 12% of the sunlight that hits it bounces back. The rest is absorbed. This is called the moon's albedo, similar to fresh asphalt actually. So when you see the moon shining brightly, remember, you're seeing sunlight that has traveled 93 million miles to the moon and then 240,000 miles to your eyes. Light, connecting worlds. The moon goes through 8 distinct phases each month. New moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, waning crescent. Each phase, a different angle of illumination, a different balance of light and shadow. Ancient peoples tracked these phases carefully. They used them to mark time, to know when to plant crops, when to harvest, when to celebrate festivals. The moon, as calendar, as guide. During a new moon, the moon is between Earth and the sun. The side facing us is in shadow, invisible. The moon rises and sets with the sun. This is when the night is darkest, when stars shine most brilliantly, when you can see the Milky Way stretching across the heavens like a river of light. The new moon, a time of darkness, but also of possibility. A full moon occurs when Earth is between the moon and the sun. The entire face of the moon, illuminated, glowing, rising as the sun sets. Full moons have names: the harvest moon, the hunter's moon, the wolf moon, each culture giving names based on the seasons, on activities, on nature. The full moon has always held special significance in myth, in folklore, in human hearts. Perhaps you can imagine the moon rises about 50 minutes later each day. This is because as Earth rotates, the moon has moved in its orbit, so Earth must rotate a little farther to bring the moon back into view. Ancient astronomers noticed this. They used it to predict when the moon would rise, when it would set. Knowledge built observation by observation, night by night. The moon sometimes appears larger when it's near the horizon. This is an optical illusion called the moon illusion. The moon's actual size doesn't change, but when it's near familiar objects, trees, buildings, mountains, our brains perceive it as larger. When it's high in the sky, with no reference points, it seems smaller. Perception, playing tricks, the mind, interpreting what the eyes see. A blue moon is the second full moon in a calendar month. Despite the name, the moon doesn't actually turn blue. The term simply refers to the timing. This happens about once every 2.7 years, because lunar months are slightly shorter than calendar months. Occasionally 2 full moons fit into 1 month, once in a blue moon, meaning something rare, something special. The moon can actually appear blue under certain conditions, when there are volcanic eruptions or large forest fires. Tiny particles can be thrown into the atmosphere. These particles, if they're the right size, can scatter red light, allowing blue light to pass through. The result, a genuinely blue moon. This happened after the eruption of Krakatoa in 1883, and after the forest fires in Canada in 1953. Nature creating beauty from disaster. A solar eclipse occurs when the moon passes between Earth and the sun. The moon's shadow falls on Earth. For a few brief minutes, day becomes night. Stars appear. The temperature drops. Total solar eclipses are one of nature's most spectacular displays. The moon perfectly covering the sun's corona, visible as the ethereal glow, like a crown of light. Pure cosmic coincidence. The moon and sun appear the same size in our sky. This is extraordinary. The sun is 400 times larger than the moon, but it's also 400 times farther away. The result, they have almost exactly the same angular size, about half a degree across. This won't last forever. As the moon moves away, it will appear smaller. Eventually, total eclipses will no longer be possible. We live in a special time. A lunar eclipse occurs when Earth passes between the sun and the moon. Earth's shadow falls on the moon, but the moon doesn't disappear completely. Instead, it turns a deep coppery red. This happens because sunlight passing through Earth's atmosphere is bent toward the moon. The atmosphere filters out blue light. Only red light makes it through, painting the moon in shades of rust and blood. Beautiful and slightly eerie. There can be up to 7 eclipses in a single year, both solar and lunar combined. though seeing one yourself depends on where you are on Earth. Solar eclipses are more common, but lunar eclipses are more widely visible because Earth's shadow is larger than the moon's. If you're on the night side of Earth during a lunar eclipse, you'll see it. Everyone on that half of the world shares the experience. Ancient peoples were terrified of eclipses. They didn't understand what was happening, the sun or moon, being devoured by some celestial creature, a dragon, a demon, a cosmic wolf. They would make noise, bang drums, shoot arrows at the sky, trying to scare the creature away, and it worked every time. The eclipse would end. The sun or moon would return. Fear and relief. If you're still awake, let your breathing deepen. Let your muscles relax. We're 1/3 of the way through. Let the facts wash over you like gentle waves. The moon creates tides on Earth. Its gravity pulls on the oceans, creating two bulges, one facing the moon, one on the opposite side. As Earth rotates, these bulges move, creating high tides and low tides. Without the moon, Earth's tides would be caused by the sun alone. They'd be less than half their current size. The moon shaping our seas. The moon also creates tides in Earth's crust, solid rock, rising and falling by several inches. You don't notice it because everything around you moves together, but it's happening right now as you lie in bed, the ground beneath you, responding to the moon's pull. Even stone bends to celestial forces. Tides have been slowing Earth's rotation. Billions of years ago, a day on Earth was much shorter, perhaps only 6 hours long. The moon's tidal pull, acting like a brake, gradually, day by day, year by year, slowing us down. In the age of dinosaurs, a day was about 23 hours. Today, it's 24 hours. In a few million years, it will be 25 hours. Time itself changing. The moon stabilizes Earth's axial tilt. Earth's axis is tilted at 23.5 degrees. This tilt gives us seasons: summer and winter, spring and autumn. Without the moon, this tilt would vary wildly, perhaps swinging from 0 to 85 degrees over millions of years. The moon's gravity keeps Earth steady, prevents these extreme variations. This stability may have been crucial for the development of complex life. Some animals time their reproduction by the moon. Coral reefs release their eggs and sperm on certain full moons, all at once. Synchronized, sea turtles come ashore to lay eggs during particular moon phases. Some insects, fish, birds, all influenced by lunar cycles. Life on Earth, dancing to the moon's rhythm. Human behavior may be influenced by the moon. This is controversial. Many studies find no effect, but some people believe. Sleep is worse during full moons. That moods change. The word lunacy comes from lunar. Ancient Romans believed the full moon could drive people mad. Perhaps it's all in our minds, or perhaps there's something to it. The debate continues. The moon, mysterious as always. 12 humans have walked on the moon, all Americans, all between 1969 and 1972, all part of NASA's Apollo program. Neil Armstrong was first, on July 20th, 1969, stepping onto the dusty surface, saying those famous words, "That's one small step for man, one giant leap for mankind." A moment watched by millions. A moment that changed history. The last person to walk on the moon was Eugene Cernan, December 14th, 1972. Apollo 17. Before leaving, he spoke into his radio. "As we leave the moon at Taurus Littrow, we leave as we came, and God willing, as we shall return, with peace and hope for all mankind. More than 50 years have passed. No one has returned, yet, but perhaps, soon. Apollo 11 landed in the Sea of Tranquility, Mare Tranquillitatis, a fitting name for such a momentous occasion. Armstrong and Aldrin spent 21 hours on the surface, only 2.5 hours outside the spacecraft, but it was enough. They planted a flag, collected rocks, set up experiments, made history, and then they left, returning to Earth, bringing pieces of the moon with them. The astronauts brought back 842 pounds of lunar material, rocks, soil, core samples from 6 different landing sites. These samples have been studied for decades. They've taught us about the moon's formation, its composition, its history. Some samples are still being studied today, still revealing secrets. The moon, sharing its story, piece by piece. There are retroreflectors on the moon, left by Apollo astronauts and by Soviet robotic missions. These are special mirrors. Scientists on Earth shine lasers at them. The light bounces back. By timing how long it takes, they can measure the exact distance to the moon, accurate to within a few millimeters. This is how we know the moon is moving away from us. Several nations have sent spacecraft to orbit the moon: the United States, the Soviet Union, Japan, China, India, Israel, the United Arab Emirates. Some missions have mapped the surface in incredible detail. Others have searched for water ice. Still others have tested new technologies. The moon continues to be explored, continues to surprise us. Water ice exists in permanently shadowed craters at the moon's poles. These craters never see sunlight. Temperatures remain incredibly cold, below -400 degrees Fahrenheit. In these conditions, water ice can survive, perhaps for billions of years. This ice could be incredibly valuable for future moon bases, for producing drinking water, breathable oxygen, even rocket fuel. The moon offering resources for those who would return. Nearly every culture has myths about the moon. The Greeks saw Selene driving her chariot across the sky. The Chinese saw Chang'e living in a lunar palace with a jade rabbit. The Norse saw Mani pursued eternally by a wolf. Someday, during Ragnarok, the wolf would catch him. Stories as numerous as stars. Many cultures have moon deities, usually feminine. The moon associated with cycles, with fertility, with the passage of time. Diana, Artemis, Luna, Hecate, Isis, Thoth, Tsukuyomi, Chandra. Names across languages, across centuries, all honoring the pale light in the sky. The moon has influenced countless works of art. Paintings, poems, songs, stories, films. Clair de Lune by Debussy. Moon River. Blue Moon. Fly Me to the Moon. Vincent van Gogh's Starry Night, with its luminous crescent. Japanese woodblock prints, showing the moon through cherry blossoms. The moon, inspiring creativity, beauty, wonder. Many calendars are based on lunar cycles: the Islamic calendar, the Hebrew calendar, the Chinese calendar. Months originally meant moons, the time from new moon to new moon. Even our modern calendar retains traces of lunar origins, though we've adjusted it to match the solar year. Time measured by celestial motion. The moon has been called many names: Luna, Selene, Cynthia, Phoebe, the names of goddesses. In science, it's just the moon, with a capital M, because it's the moon, our moon, the only one we have. Other planets have moons, but ours is special. Halfway through, your eyelids growing heavy, Your breath slowing. That's good. That's perfect. Let the facts drift over you, like moonlight through a window. For centuries, people wondered how the moon formed. Was it captured by Earth's gravity? A wandering body, passing too close, trapped in orbit? Was it formed alongside Earth? A twin world, born from the same material? Or was it somehow spun off from Earth itself? Perhaps when our planet was spinning so fast that a piece broke away. Each theory had its problems. The capture theory couldn't explain the moon's orbit. The co-formation theory couldn't explain why the moon lacks iron. The fission theory required Earth to spin impossibly fast. Questions without answers until recently. The giant impact hypothesis is now the leading theory. The collision with Theia, the debris ring, the coalescence. This theory explains many things. Why the moon has so little iron, why its composition is similar to Earth's mantle, why it's so large compared to Earth. Computer simulations show that such an impact could have happened. The angle had to be just right, not head-on, but glancing. About 45 degrees, too direct, and both bodies would have been destroyed completely. Too shallow, and Theia would have bounced off. Evidence from computer simulations, from lunar samples, from orbital mechanics. The pieces fitting together. Some material from Theia likely still exists in the moon, mixed with material from Earth, blended together in the heat of impact. When you look at the moon, you're seeing two ancient worlds, merged, unified. Scientists estimate that perhaps 60 to 80% of the moon came from Earth's mantle, the rest from Theia. So the moon is mostly Earth, with a piece of another world mixed in, like a cosmic recipe with ingredients from two different sources. A cosmic merger, written in stone. The early moon had a magnetic field. Ancient lunar rocks contain magnetic minerals, aligned in ways that indicate the moon once had a dynamo, a liquid core, generating magnetism. But the moon is small. It cooled quickly. The core solidified. The magnetic field died. This happened gradually, over hundreds of millions of years, between 4.2 and 3.5 billion years ago. As the moon's interior cooled, the dynamo weakened, sputtered, eventually stopped, like an engine, running out of fuel. Today, the moon has no global magnetic field, only weak, localized patches, remnants of the past. The moon may have had a thicker atmosphere early in its history. When it was volcanically active, eruptions would have released gases, water vapor, carbon dioxide, sulfur compounds. For a few 100 million years, the moon might have had a thin atmosphere, thicker than today's near vacuum, but still far thinner than Earth's at its peak. This atmosphere might have been as thick as Mars's atmosphere today, perhaps even thicker, enough to create a faint haze when viewed from Earth, enough to transport heat slightly from the day side to the night side. Eventually, these gases escaped, lost to space, because the moon's gravity isn't strong enough to hold them. The highest point on the moon is 10,786 meters above the mean, located near the lunar equator, higher than Mount Everest. The lowest point is at the bottom of the South Pole Aitken Basin, about 9,000 meters below the mean. Total elevation difference, nearly 20 kilometers. The moon is not smooth. If you could stand at the highest point and look toward the lowest, the view would span almost vertical miles of lunar landscape. Mountains and valleys, created not by plate tectonics like on Earth, but by impacts and volcanic flows. A landscape shaped entirely by violence and fire. Despite having no atmosphere, the moon has dramatic terrain. Tycho crater is one of the moon's most recognizable features. It's bright, very bright, with rays of ejected material stretching thousands of kilometers across the surface. These rays are visible from Earth, even with the naked eye. They make Tycho look like a bright point, with lines radiating outward. The crater is only 108 million years old, relatively young, still fresh. The impact that created Tycho threw material enormous distances. Some rays extend more than 1,500 kilometers. That's like debris from an explosion in London, landing in Rome. The ejected material, lighter colored than the surrounding terrain, creates this striking pattern, a cosmic splash, frozen forever. The moon has rills, long, winding channels. Some are collapsed lava tubes, others are cracks in the surface. They snake across the Maria, sometimes hundreds of kilometers long, created when the lava flows. Were still partially molten, still flowing. From orbit, they look like dried riverbeds, but they never carried water, only stone. One of the largest is Hadley Rill, where Apollo 15 landed. Astronauts drove their lunar rover right to its edge, looking down into the channel, carved by lava billions of years ago. Some rills are over a kilometer wide and hundreds of meters deep, ancient rivers of molten rock. There are domes on the moon, low, rounded hills formed by viscous lava, too thick to flow far. Instead, it piled up, creating these gentle rises. Some domes have small craters at their peaks, volcanic vents, now silent, cold. These domes are typically only a few hundred meters tall, but can be 10 or 20 kilometers across, broad and gentle, like blisters on the lunar surface, where magma pushed upward but couldn't quite break through completely. Scientists have identified hundreds of these features scattered across the Maria, evidence of the moon's fiery past. The moon has wrinkle ridges, long, sinuous folds in the Maria, created when the lava flows cooled and contracted. The surface, buckling, folding. They're not tall, only a few hundred meters, but they stretch for hundreds of kilometers, proof that even stone can wrinkle, given time. The moon's gravity is about 1/6 of Earth's. If you weigh 150 pounds on Earth, you'd weigh 25 pounds on the moon. You could jump 6 times higher, lift objects 6 times heavier, but you'd still have the same mass, the same inertia. The astronauts found this strange. They bounced when they walked, like kangaroos, in slow motion. This weaker gravity means you could theoretically jump 3 meters high on the moon, about 10 feet. Imagine the sensation, pushing off the ground, rising slowly, hanging in the air, then drifting back down. Every movement, dreamlike, surreal, as if the universe itself had changed its rules. Sound does not travel on the moon. No atmosphere means no medium for sound waves. If 2 astronauts stood side by side, they couldn't hear each other speak, unless their helmets were touching. All communication had to be by radio. Silence, pure, complete. Only your own breathing, your own heartbeat. Imagine walking across that landscape, your footsteps, completely silent. No wind, no rustle, no ambient noise whatsoever. Just you and the quiet, the most complete silence any human has ever experienced. Some astronauts found it peaceful, others unsettling. Imagine that. Temperatures on the moon vary dramatically. In sunlight, the surface can reach 127 degrees Celsius, hot enough to boil water. In shadow, temperatures plunge to minus 173 degrees Celsius, colder than liquid oxygen, without an atmosphere to distribute heat. The difference between light and dark is extreme. Step from sunlight into shadow, and you move from an oven into a freezer. Instantly, your spacesuit would have to protect you from both extremes. Some areas on the moon experience temperature swings of 300 degrees, more extreme than anywhere on Earth, more extreme than most places in the solar system. The moon, a world of contrasts. A day on the moon lasts 29.5 Earth days, from sunrise to sunset, about 2 weeks, then darkness for another 2 weeks. Imagine days that last for weeks, nights equally long, time moving differently. For future moon bases, this will be a challenge. 2 weeks of continuous sunlight, 2 weeks of freezing darkness. During the lunar day, solar panels would generate power continuously, but during the night, everything would rely on batteries or nuclear power. The transition from day to night would happen slowly, shadows creeping across the landscape over hours, sunset lasting for days. Planning will be essential. The moon has moonquakes, similar to earthquakes, but caused by different forces. Thermal stress as the surface heats and cools, tidal stress from Earth's gravity, meteorite impacts, deep moonquakes occur about 700 kilometers below the surface. Shallow moonquakes are less common but more powerful. Apollo astronauts left seismometers on the moon. These instruments detected thousands of moonquakes, some caused by the rapid heating at sunrise, the surface expanding, cracking, others caused by Earth's tidal pull, kneading the moon's interior, like flexing a piece of metal until it breaks. The moon, still active, in its own way. The moon's core is small, only about 350 kilometers in radius. That's roughly 20% of the moon's total radius. Earth's core is about 50% of its radius. The difference explains why the moon has no magnetic field today. Small core, less heat, no active dynamo. This small core is probably solid iron, with perhaps a thin layer of molten iron around it. The core makes up only about 1 to 2% of the moon's mass. Compare that to Earth, where the core is about 30% of the mass. The moon is mostly mantle and crust. It's hard, tiny and cold. A small engine, long since stopped. The moon's interior is divided into layers. The core, probably solid iron, perhaps with some liquid surrounding it. The mantle, dense rock, different composition at different depths. The crust, lighter rock, thicker on the far side than the near side. Structure, revealed by seismometers, left by Apollo astronauts listening to moonquakes. The crust averages about 50 kilometers thick on the near side, but can be up to 150 kilometers thick on the far side. Why this difference? Perhaps the near side stayed warmer longer, more volcanic activity, thinner crust. The moon, asymmetrical, uneven, like it was built in 2 different sessions, with different blueprints. We don't fully understand why the moon's far side is so different. Thicker crust, fewer maria, more craters. Some think when the moon formed, it had 2 magma oceans. One cooled faster, creating the asymmetry. Others suggest tidal heating from Earth, keeping the near side warmer, more volcanically active. Perhaps Earth's gravity pulled on the molten moon, causing the near side to remain liquid longer, allowing more lava to reach the surface. Or perhaps the far side cooled faster because it faced the cold of space, while the near side bathed in Earth's heat, radiation from our young planet, keeping one hemisphere warm. The mystery persists. There may be a second, smaller moon made of debris at Lagrange points. These are positions where Earth's and the moon's gravity balance. Objects there can remain relatively stable. Dust clouds have been detected at these points, called Kordylewski clouds. They're faint, elusive, but they might be real, temporary companions to our permanent moon. These clouds exist at the L4 and L5 Lagrange points, 60 degrees ahead and behind the moon in its orbit. The dust particles, trapped there by the gravitational balance, swirling slowly. Some astronomers doubt they're real, just tricks of light. Others insist they've photographed them, ghosts in the orbital dance. The moon's origin might have involved multiple impacts. Some models suggest Earth was hit not once, but several times by smaller bodies, each impact adding material to the debris disk, eventually all coalescing into the moon. Multiple collisions instead of one giant impact. The details still being worked out. Perhaps Theia wasn't alone. Perhaps several Mars-sized bodies struck Earth over a span of millions of years, each adding to the ring of debris until enough material accumulated to form our moon. This would explain some of the chemical variations, some of the puzzling data, multiple ingredients mixed together. Science refining its understanding. Ancient moon rocks contain oxygen isotopes identical to Earth's. This supports the impact hypothesis because it means the moon and Earth's mantle are made of the same material. If the moon formed elsewhere and was captured, its isotopes would be different. Chemistry telling the story of shared origins. Oxygen has 3 stable isotopes. Their ratios vary slightly across the solar system. Each planet, each asteroid has a unique signature, like a fingerprint. But Earth and the moon have identical oxygen isotope ratios. Identical. This is powerful evidence that they share a common origin, born from the same material in the same region of space. The moon is slowly tidally locking Earth as well. Just as Earth has locked the moon is locking Earth. But this process is much slower. In billions of years, Earth's day will equal the moon's month. Both worlds showing the same face to each other forever. But the sun will likely die before this happens. When mutual tidal locking is complete, one side of Earth would always see the moon, hanging motionless in the sky, never rising, never setting. The other side would never see the moon at all, a divided world, half with moonlight, half without. But this future is so distant, it's purely theoretical. Time, measured in eons. Your breathing. Is it deeper now? Are your thoughts drifting? Good. Let them drift, like clouds, like the moon across the sky. In about 50 billion years, if the sun didn't expand, Earth and moon would be mutually tidally locked. The same faces, always turned toward each other. The moon hanging motionless in Earth's sky, never rising, never setting. From half of Earth, you'd never see the moon. From the other half, it would be permanent. But the sun will become a red giant long before then, swallowing both worlds. The sun has about 5 billion years of normal life left. After that, it will expand, growing larger and larger. Eventually, its outer layers will reach Earth's orbit. Both Earth and moon consumed, vaporized, return to the cosmic dust from which they came. The end, written in stellar physics, Plans are underway to return humans to the moon. NASA's Artemis program, China's lunar ambitions, private companies developing lunar landers. The goal is not just to visit, but to stay, to build permanent bases, the moon as a stepping stone, to Mars, to the asteroids, to the stars beyond. Artemis aims to land the first woman and first person of color on the moon, to establish a sustainable presence, a lunar gateway station, orbiting the moon, surface habitats, where astronauts can live for months, mining operations, extracting resources, the moon, no longer just a destination, but a home, a workplace, a launch pad for deeper exploration. The moon might be a source of valuable resources, helium-3, a rare isotope, useful for nuclear fusion, abundant in lunar soil, rare earth elements, titanium, other minerals, water ice. As mentioned before, essential for life support. The moon, not barren, but rich, waiting. Helium-3 is incredibly rare on Earth, but relatively common on the moon, deposited by solar wind over billions of years. If we ever develop fusion reactors, the moon could power humanity for millennia, and the rare earth elements used in electronics, batteries, magnets could be worth trillions. The moon, a treasure chest, if we can learn to open it. Some propose building telescopes on the far side of the moon, shielded from Earth's radio noise, perfectly stable ground, no atmosphere to distort signals, radio telescopes that could see deeper into the universe than ever before. The moon as an astronomical platform. The far side of the moon is the quietest radio environment in the inner solar system. No cell phones, no satellites, no interference, just silence, perfect for listening to the faint whispers of the early universe, to the cosmic microwave background, to signals from the first stars born in the cosmic dawn. The moon as our window to the beginning of time. Solar power works very well on the moon. No clouds, no atmosphere to block sunlight, 2 weeks of continuous exposure. Solar panels could generate enormous amounts of energy, enough to power bases, mining operations, manufacturing facilities. The moon, lit by the sun, offering power near the poles. There are peaks of eternal light, mountains so tall that they are almost always in sunlight. Even during the lunar night, these would be ideal locations for solar power stations, generating energy continuously, or nearly so. And the vacuum of space means solar panels don't degrade from weather. They could last for decades, perhaps centuries. There's something called earthshine. When the moon is a thin crescent, you can sometimes see the dark part glowing faintly. This is light from Earth, reflecting off the moon. Then back to Earth. Earth, as the moon's moon, illuminating its night side. Beautiful, reciprocal. Da Vinci was one of the first to correctly explain this phenomenon. He realized that Earth shines just as the moon does, reflecting sunlight, and that light reaches the moon's night side, making it glow softly. The old moon in the new moon's arms, poets called it, a gentle embrace of light between worlds. The moon can create its own light, in a way. When high-energy cosmic rays or solar particles hit the lunar surface, they can cause the regolith to glow very faintly. This is called cathodoluminescence, invisible to the naked eye, but detectable by instruments. The moon, glowing in the dark, like the faintest ember. This glow is most intense during solar storms, when charged particles from the sun strike the surface. The minerals in the regolith, excited by the energy, emit light, red, orange, sometimes blue, too faint for humans to see, but spacecraft instruments detect it. The moon, responding to the sun's touch with its own quiet luminescence. There are mysterious transient lunar phenomena, brief flashes of light, colored glows, areas that seem to change. Amateur and professional astronomers have reported these for centuries. Most occur in certain areas, like Aristarchus crater. Causes unclear. Perhaps gas releases, electrostatic discharges, meteorite impacts, or perhaps tricks of light and shadow. The moon, keeping secrets. Some reports describe red or pink glows, lasting for minutes. Others, brief white flashes. The Moon Blink program in the 1960s tried to document these events systematically. Some were explained, but many remain mysterious. Outgassing from the interior, static electricity from dust, or something else entirely. The moon, still surprising us. The moon has a very thin exosphere, not an atmosphere, but a scattering of individual atoms, sodium, potassium, helium, argon, so thin, it's essentially a vacuum, but it's there, created by solar wind, radioactive decay, micrometeorite impacts, atoms briefly escaping the surface before settling back down. Some areas of the moon have magnetic anomalies, small regions with stronger magnetic fields, called magnetic anomalies or mini magnetospheres. They might protect against solar wind. In small areas, scientists are studying them to understand their origin. Remnants of ancient magnetism, frozen in stone. The moon has helped us understand deep time by counting craters and knowing the rate of impacts. We can estimate the age of surfaces. The heavily cratered highlands are ancient, the smooth Maria, younger. Crater counting, a clock, measuring billions of years. The moon preserves a record of the inner solar system's impact history. Every crater is a timestamp, evidence of a collision from a particular era. There was a period called the Late Heavy Bombardment, about 4 billion years ago, when impacts suddenly increased. The moon's face, scarred by this violence, remembering, recording. Studying the moon helps us understand Earth's early history. Earth's ancient surface has been erased by plate tectonics, erosion, volcanic activity, but the moon preserves its early history. No tectonics, no erosion, just craters, lava flows, frozen in time. The moon as Earth's memory, holding what we have forgotten. The moon's orbit is slowly becoming more circular. It's currently slightly elliptical, but tidal interactions are gradually making it more circular. In millions of years, the orbit will be nearly a perfect circle. Gravity, smoothing, perfecting. The moon's rotation wasn't always synchronous. Billions of years ago, it rotated faster, showing different faces to Earth. Over time, tidal forces slowed it down until rotation matched orbit, a process taking hundreds of millions of years. Gravity, patient, inexorable. Several countries have crashed spacecraft into the moon deliberately to study the debris plumes, to search for water, to analyze composition. When these impacts occur, observatories on Earth and in orbit watch carefully. The moon, revealing its secrets. When struck, there are several rovers currently on the moon. China's U-2 rovers, exploring the far side, the first to do so. They drive slowly, carefully, analyzing rocks, taking pictures, sending data back to Earth. Robots, where humans haven't yet returned. Future missions plan to explore the moon's lava tubes. These are tunnels left by ancient lava flows. Some are enormous, large enough to contain entire cities. They're shielded from radiation, from temperature extremes, from micrometeorites. Perfect for future moon bases, natural shelter, waiting to be used. There's a proposal to build a lunar ark, a repository deep inside a lunar lava tube, storing samples of Earth's biology, DNA, seeds, embryos, a backup in case something happens to Earth. The moon as vault, as sanctuary, as hope. Some scientists propose mining the moon with robots, autonomous machines, building more machines, creating infrastructure, humans directing from Earth, but not directly present. The moon industrialized, without human hands, at least at first. Are you still with me? Or are you drifting into sleep? Either way is perfect. The moon watches over dreamers. The moon is the second brightest object in Earth's sky, after the sun, brighter than any star, any planet. A full moon can cast shadows, can illuminate landscapes, turn night into twilight. Moonlight, strong enough to read by. For those with good eyes, the moon appears different colors at different times. Usually, it's grayish-white, but near the horizon, it can look yellow, orange, even red. This is because light from the moon passes through more atmosphere. Blue light scattered away, red light passing through. The same reason sunsets are red. You can sometimes see the moon during the day. It's not only a nighttime object. For much of each month, it's visible in daylight. Look carefully. When the moon is in its quarter phases especially, there it is, pale, ghostly, sharing the sky with the sun, day and night, together. The moon moves across the sky from east to west, like the sun, like the stars, because Earth rotates. But if you watch carefully, over hours, you'll notice the moon's position among the stars changes. It's moving in its orbit, from west to east, about 13 degrees per day, slow motion, visible to the patient observer. Different cultures see different shapes in the moon's maria. Western cultures see a face, the man in the moon. Chinese and Japanese cultures see a rabbit, pounding rice, or medicine. Some cultures see a woman, a frog, a buffalo, the moon, a mirror, reflecting our imaginations. The moon is the only celestial body beyond Earth that humans have touched. 12 sets of boots, 6 landing sites, flags, equipment, footprints. We've been there. We've walked on another world. That alone is extraordinary. In all of human history, in all our million years, only in the last 50 have we left our planet, and we chose the moon. The moon will outlast humanity. Long after we're gone, the moon will still orbit Earth, still reflecting sunlight, still raising tides. It existed for billions of years before us. It will exist for billions of years after. The moon, eternal, or as close to eternal as anything we know. Every night, the moon is there, sometimes bright, sometimes dark, sometimes hidden by clouds, but always there, a constant in a changing world, a reminder that some things endure, that beauty exists, that we're part of something vast. When you look at the moon, remember, you're seeing something ancient, something that has watched over Earth since the beginning. The same moon that dinosaurs saw, that early humans looked up at, that inspired our ancestors to wonder, to dream, to reach for the stars. The same moon that's still there tonight, watching, waiting, glowing softly, our closest companion in the cosmic dark. "100 facts about the moon, from its violent birth to its current slow journey away from us, from its craters and seas to its influence on Earth, From ancient myths to future missions, the moon has been with us through everything, and it will be there tomorrow night and the night after, and every night for as long as humans look up at the sky. Perhaps tonight, when you drift off to sleep, you'll dream of the moon, of lunar landscapes, silver dust, black sky, the earth rising over the horizon, of a place silent, beautiful, waiting for us to return. Let these stories, these facts, these wonders settle into your mind, like moon dust settling after an astronaut's footstep, slowly, gently, finding rest. Your breathing is slow now, deep, even. The moon pulls at the tides, pulls at your dreams, draws you towards sleep. Let it. Let the moon watch over you tonight, as it has watched over Earth for 4.5 billion years. May these stories lull you to sleep. Good night.